Good morning, guys. Hello. Could you comment your name so I know who's here and I can do a register? Still got no comments. Oh, there we go. Cool. Caleb, hey Caleb. Cool. All right, let's fill in this register. So Caleb, Alex, Roddy, Callum, Becca, Sophie, Fifi. Cool. Got any Charlie, Joan, George, or Leo so far? Don't know. All right. Yeah. So first of all, I need to go over some things for the mock next week, so you guys know what's happening. So, first thing, you are off timetable. So there won't be any scheduled lectures. Although if you guys do need any help with any revising that isn't on the test, you are welcome to email me and we can do a Teams chat or whatever. Okay, your exams are Monday to Wednesday. It's up to you when you do them. We advise you kind of do them in the same slots as you would have had lectures, but it's completely up to you when you do the exams. Yep. The mocks will be available on Moodle. In the morning, so I think I start college at 9:15 a.m. on Monday. That's that. It's about 9 o'clock on Monday morning. So you've got a core exam, a pure exam, in my lectures, so I'm going to be marking the pure, although it doesn't really make a difference because you're doing it on your own time. But pure in strand 1, which is me, and you got applied in strand 2, which is Helen's one. And you've got 2 hours for each exam. So I know it applied says stats and mechanics, but it's 2 hours in total. So you're going to have to divide your time up between stats and mechanics. We want you guys to do the papers, scan them in if you can. Hopefully you can send us the scans. If you can't do a scanner, you possibly could take photos of it, although I'm dubious as to what kind of resolution they'll come out as, but you can try that. Or you might have to post your answers to college as it's described on the internet page. The formula book is on Moodle. You need your calculators. Yeah, cool. And then we're going to be marking the mocks on Thursday and Friday, and then we'll be going through the mocks the following week. So hopefully you'll still have the original papers. Keep those downloaded, and keep your answers as well, so we can go through those, which would be quite good. Yeah, and then you guys will be able to mark your own, and we can compare marks. Cool. After the mock's been covered, we're going to start teaching further maths, so that'll be fun. That's going to be I guess 3 weeks time, so just before half term. So yeah, that's the plan. Has anyone got any questions about the mock exams before we get on with what I want to do today? Nope, everyone all right? Okay, so get revising and make sure you're prepared for those, and we'll see how those go. So last lecture we were doing past paper. We got 2 questions left to do, so we're going to finish this one off today, and then after that we're going to have a look at some some approaches to how to deal with modeling questions, because I know people always find them hard. So we can start with this one. This is a 6, 10, 11 mark question. We off timetable all week. Yep, all week. You won't have anything to do on Thursday and Friday. So Thursday and Friday is kind of like an extra weekend for you guys. Monday, Tuesday, Wednesday is mocks, and then Thursday, Friday is day off, so your lecturers have a chance to get some things marked. Alright, so I'm going to give you guys 11 minutes for this one, starting from now. Joan, why are you late? You missed some key stuff about mocks, so make sure you look back through the beginning of this video so you understand what's going on next week at some point. Charlie, can you make sure you watch the beginning of the video as well, because you've missed some stuff on the mocks next week. Alright, so missing George and Leo. So George, Leo, if you're here, please comment. Cool, George, make sure you watch the beginning of the video so you know what's going on with mocks next week, and please try and arrive on time next week. Not that hard. I think you'll be looking at matrices of Helen and complex numbers of me. I think that's the plan. So new concepts, slightly more challenging. Well, for complex numbers, slightly more challenging concepts, but it's standard stuff. You guys will be fine with it. All right, let's go through this one. Um, cool. All right, let's have a look. So, first bit looks like a trapezium rule. So we've got to fill out the rest of this table. So we're going to put in 1.5 as x to get half of 1.5 cubed times the square root of 4 take 1.5 squared, which gives you 2.2. Does that look right? Possibly 2.23. Cool. I think that's right. It seems a bit. Well, I guess it goes up and then back down. Okay, use trapezium rule with 4 equal strips. So trapezium rule. All right. So we've got a strip width of 0.5. So there's our trapezium rule. So we get half 0.5. That's our width of 0 plus 0 plus 2 lots of 0.12103 plus 0.86603 plus 2.2. Maybe I should use more decimal places. 2.2323. Cool. So be careful how you type this in. So we can have 0.5 times 0.5 times brackets 0.12103 plus 0.86603 plus 2.2323. Close the brackets. So you should get 0.8. Wait, did I times those by 2? No, I forgot to times mine by 2. Yeah, be careful with that. To get 1.610. 2 4 sig figs. Yeah, correct 5 decimal places. Yeah, sorry. 2.2324 or 23235. Yeah, there you go. Alright, so I should have put 5 in there as well. Yeah, it doesn't really change the answer very much. So yeah, 1.610 to 4 sig figs. Okay, now we've got integration by substitution, which is always a favorite of students. So trying to integrate that thing. Right, what substitutions did you guys go for? What did you go for you? Roddy went for 4 minus x squared. Cool, yeah, I think that will work. Anyone use anything different, or should we just go through that one? So if u is 4 minus x squared, du over dx is minus 2x. So dx is du over minus 2x. So that's going to change our integral into the integral of root u du over minus 2x times half x cubed. So we've got x cubed on the top and we've got x on the bottom, so that's going to simplify to give us a quarter. We need a minus in there as well, so I'm going to stick a minus out the front. X squared root u du. We just need to change the x squared now. So we can go back to our original equation over here and say, well, x squared is 4 minus u squared. So that's going to be minus a quarter of 4 take u squared root u du. So it's all in terms of u now, which is good. We just need to work out our new limits. So I'm going to put my old limits, which were 0 and 2, into the u equation. So u equals 4 minus, what am I doing? U equals 4 take 0. So when x is 0, u is 4. And when x is 2, u is 0. So confusingly, our limits are upside down. So we got our 0 on top and our 2 on the bottom. That's fine because you've got a minus sign. We're allowed to flip those limits round. So last step is simplifying this. We're going to get minus integral 0 to 2 of a quarter. Well, actually, we're not. If I expand the brackets as well, we're going to get root u minus u to the 5 over 2 over 4 du. So that is the integral which I need to do. Oh no, I need 4. It's not 2, is it? The limit should be 4. There we go. And there shouldn't be a minus there. I don't know why I copied that minus again. That should be it, because I flipped my limits. So that should be my integral. Cool. I think that's right, isn't it? 2. Yeah, limit should be 4. Cool. Everyone in agreement with that? I think it's 5/2. Just looking at the mark scheme, they've got they got 3/2. Where they got 3/2 from? It was oh shit, yeah, it's 4 minus u, isn't it? There shouldn't be a u squared there. There we go. So yeah, that should be 3/2. It's me copying badly, that is. Cool. Okay, so do the integral. I'm just going to clear a load of space. So that's our question. Let's do it. So we're going to get so that's u to the half. So we increase the power, so we're going to get u to the 3/2 times by 2/3 minus we're going to get u to the 5/2, and it's going to be 1/10, I think there. 2/5 times 4, 2/20, 1/10. Yep. And we've got our limits. Of is it 4 on top, 0 on the bottom? So we're going to get, I guess we need to do this exact value, yeah. So we got 4 to the power 3/2, so that's going to be 8, so we get 16/3, minus 4 to the power 5/2, so that's going to be, is that 32? Yeah, 32/10. Take away, well, if we put 0 in, we get 0, so we need to show that we've considered that bracket, but that's what we get. So we need to do 16/3, take 32/10, and we should get 61. Oh, wait, again, something's gone wrong here. Hmm. 'Is what you guys are getting to? I think something's gone wrong here. 4 to the power 2.5 over 10. Yeah, 32/10. What am I doing wrong? Um, 16/3. Take 32/10. Gives me 32 oh, no, I did it right. I just typed it in like an idiot. Okay, so we get 32/15. Cool. All right. Okay, so there's one way you could improve your estimate. What's the classic way of improving trapezium rule is more trapezia. Or more strips, whatever you want. Cool. Right, barring a few mistakes, that one wasn't too bad. Last one then is this trig one. So it looks like an R method question to do with pottery. Interesting. So it's a 12 mark question. I'll give you guys 12 minutes to do it. And then we've done this paper. So pretty good work this week. There you go. Could you be marked down if you put trapeziums? No, I think you'd be alright. The answer in the exam is more strips, but I think they care about what you mean rather than your what's the word? Your collective nouns, isn't it? Collective nouns? Yeah, something like that. Oh, yeah. No, I think you get the marks for that, Callum. Hello. Cool. I don't see any answers, guys, but if you could comment, that'd be good. Right. So for our method. All right. So we've got trying to put it in this form. So the first thing I'd suggest with our method is to expand the trig. So you get r cos theta sine. Nope. Ready mucked it up. R sine theta. No. R cos theta cos alpha minus r sine theta sine alpha. There we go. I'll just bring the screen down a bit. There you go. Cool. All right, so that's what we're trying to compare it to. So 5 then must equal r cos alpha, and 8 must equal r sine alpha. So we square and square root these to find r. So we're going to get r squared, red, r squared equals 5 squared plus 8 squared. We can divide these to get tan alpha is 8 over 5. So with those two bits, I can find r and alpha. So we get root 89 as r. Let's just make some space. And alpha, we want to do it in radians, so make sure your calculator is set up for radians. Inverse tan of 8/5. And yeah, Roddy, well done. So you get 1.0122. Correct to 4 decimal places. Yeah, good. Okay, cool. So that's the easy part. That's the standard bit. Now we have to relate that, turn that into a model. So our temperature, we're going to basically compare their model with where we started and then use that to adjust our, well, I haven't actually written our answer here anyway. Root 89 cos theta plus 1.0122. So we're going to adjust the equation in blue using the changes they made between the two red equations. So our model is going to turn into temperature equals, now they've got 1100 there, so we're just going to add that on, 1100 plus, the model's the same, still got 5 cos and 8 sines, so that's nice and easy, plus root 89 cos of, now instead of theta, they've got x over 3, so we're going to change my theta into x over 3 plus 1.0122. So there, we've adapted their model to be an R method model. And we want to work out the maximum temperature. So the maximum temperature, well, let's think about what cos looks like. Cos is a graph that looks like this. The maximum of a cos is 1. So this bit has a maximum of 1. When you times that by root 89, we've got a maximum of root 89. And if you add 1,000 to that, our max value is going to be 1,000 plus square root of 89, which gives me 1009.43. So that's in degrees C. It's pretty hot. And we want to find the x value where the maximum occurs. So where it first occurs. All right, so looking at our graph, our first value would be there. But our cos graph has been translated to the left. So it's going to move that way. So that value is going to disappear. So our value that we want to find is this value here. And that value is the angle is 2 pi. So I'm going to set my angle up here equal to 2 pi. So 2 pi equals x over 3 plus 1.0122. And then rearrange for x. So 2 pi, take 1.0122, and then times it by 3, and we get x equals 15 point, so was it 1 or 2? 2 decimal places. 15.81 for that. Cool. Everyone okay so far? I mean, you could do all this on a graphical calculator with some sketches. Okay, the last bit. Calculate times when the temperature is predicted to be exactly 1097. So we're just trying to solve some trig now, so this is relatively straightforward. Wouldn't it be 1109? What did I say? I've just deleted that. What does it say to max value of t? No, it doesn't say we have to round it. The only thing it says is yeah, I read that as both of them to 2 decimal places, so I don't know why you guys are rounding it. Let me consult the mark scheme in a second. Oh. No, mark scheme says it's what I've got, so I think they've just rounded both of it to 2 decimal places. It doesn't say to the nearest hour, so it doesn't say to the nearest degree, so I wouldn't. I added it wrong. What? Well, I don't know what you guys are saying. We are rounding it, which is more than your maximum answer. The next question is 1097. Oh, what have I done? Oh, 1109. Oh yeah, I wrote 1,000. Yeah, okay, cool, fairs. Yep, that should be. Sorry, guys. Yeah, 1109. Well spotted, because I'd left out the 100. Cool. All right. Last bit then is to, yeah, just as I was saying, just solve some trig. So we're trying to solve that massive equation when the temperature is 1097 equals 1100 plus root 89 cos x over 3 plus 1.122. Okay, 1097. Take 1100 divided by root 89 gives us, we do want temperatures times in the first 24 hours, yeah. So we get minus 0.318 equals cos x over 3 plus 1.0122. Right, so on the times during the first 24 hours. Alright, so we're going to find a few different x values, or a few different angles. So we'll find the primary angle first. So if we arc cos that, we get theta. Theta is 1.89. Maybe it's be more exact, 1.894. So I'm going to sketch cos. And I'm going to find a few of these because I'm not sure where we're going to need to stop coding this. So 1.89 is, how does that compare to pi? That's less than pi. Is it less than pi by 2? Let's see. 1.5. So it's slightly more than pi by 2. So it's looking like it's going to be here. So we're going to get 1, 2, 3, 4. I'm going to find 6 and we'll see where we get to. We might need to find more or we might overcalculate it, but we'll find out what these 6 are and go from there. So we're going to have 2 pi minus that for our next value. So 2 pi oh, dear. So we get 4.39, and we rounded that to 3dp. Next value is going to be 2 pi plus, so 2 pi plus 1.894, giving me 8.177. So that's those three. We're then going to use 4 pi take 1.894, 10.67 for that one. 4 pi plus for the next one. To get 14.46. And then lastly, 6 pi take 1.894. Right, 16.95555, so that's going to be 16.9. Oops. 96. Okay, so those are my values. We probably got too many, but thought may as well get them all done at the same time. You could, of course, plot all this on the calculator and work it out a lot quicker. So those are my theta values. I need to now code those. So for each value, I need to do so x over 3 plus 1.0122 equals all those values. So I need to take away 1.022 and then times it by 3. Right, bear with me while I do this. So we get x equals 2.645. So was it 1 and 2? I can't remember what the question said now. Calculate times 2b. Okay. So 2.645. We're going to get 4.39 take 1.0122 times 3 gives me 10.133. 8.1 take away 1.0122 times by 3 gives me 21.49. I don't think we're going to get any more. We'll try one more of these though. 10.67 take 1.0122 times by 3. Yeah, we're over. So those are our 3 answers. Cool. Everyone right with that? Okie dokie. So that's the whole paper. Hopefully you guys found that all right. That was a pretty standard kind of paper. Do we need to put as 2 hours or just decimals? You should probably write hours at the end of it. They are going to be decimals, but you ought to include your units. So yeah, write the word hours at the end of it. Cool. Right, we've got a half hour-ish left today. I wanted to talk about modeling. And my idea for this was let's make a load of modeling equations based on just 2 data points. And we'll see how this goes. I've not tried it before. It's an idea I had, so we'll see what happens. So we're going to say data. No, not data is represented. We'll give you 2 data points. So those are our 2 data points. I've just randomly made those up. And we're going to try and fit a load of different models to this data and compare them and look at the different methods in which we can find models. So I'm going to say this is data for what should we say? 560, 30, 2800. Let's say it's the I don't know. I've got no ideas today. I'm quite tired. What would go up in 5 to 30? So it looks like it's exponential data. Let's say it's the I cannot think today. No, let's not just leave it here. We need a name for this data. What could it be? Exponential rise. Let's say it's okay. We'll have where x is the vintage in years of a red wine, and y is the cost per bottle. That's not bad for something. Yeah, we could use coronavirus case. If you want to use coronavirus cases, you can. But I thought that was too topical, so I changed my idea to the worth of some wine. But up to you. If you want to do coronavirus, you can. So that's my data. What I want you guys to do first of all is to come up with a linear model linking. So we're going to use V for vintage and C for cost. So first of all, can you guys come up with a linear, find a linear model. So it should be nice and easy. Find me a linear model for this wine. Give it a go. So I'll give you 5 minutes, should be enough. So find me a model that describes the relationship between cost and vintage of this wine, or between days and cases of this coronavirus. Cool. Right, give it a go. 5 minutes starting from now. Cool. Right. What have you guys gone for? Anyone got any equations? So we said v is x and c equals y. Cool. So we need to find a gradient. So we're going to do 2800 minus 60 over 30, take 5. Which gives me a gradient of 111.76. And my y-intercept, well, we can just put that into one of these points now. So we do y minus 60 equals 111.76, x take 5. I shouldn't really be using y and x, so let's just quickly tweak those and turn them into c and v, plus 618.8. So you can say the cost of a bottle of wine is 111.76 times its vintage plus 618.8. Does that make sense? No, no, it does not. I've done something stupid. Should be negative, right? Got a different gradient. 2800 minus 60 over 30 take 5. Let me double check them. And I know I made a mistake later. Divided by 25. Oh, 109. Yeah, weird. 109.6. Scrap all that, I'll do it again. So, C take 60 equals 109.6. X take 5. C equals 109.6. X minus 488. Is that what you guys got? Do you agree now? Cool. Right, I'm just going to write this down separately. Could you guys predict the cost of a bottle of wine that's 100 years old then, please? Cool, and what'd you get? Yeah, that actually be V, sorry. How do I do that? V and V. Cool. Yep, 10472. Yeah, that's correct. Good. All right, now could you guys try? I've written that down, so we'll keep that for later. Now can you guys try a exponential model? How? All right, so we're going to imagine that we've got 2 points on an exponential graph. So we could say an exponential model might be C equals A e to the power kv. So we're saying it's an exponential that we've stretched to fit our 2 data points. So we can imagine we've got 2 data points on a graph. What we just did was find a linear model. What I'm proposing now is we're going to stretch an exponential model to fit the same data points. So you've got 2 data points, you've got your exponential model. See if you guys can work it out. You're going to need to do 2 equations, and you're going to need to solve them simultaneously to find any unknowns. I'll give you guys, I think, probably 6 minutes to try this one. So give it a go. If you still need help after 6, I'll give you a bit longer, but try this one. Cool. Right, how do you guys get on? K minus 0.154 and A is 27.82. Yeah, that's what I got as well. Cool. Right, we'll just go through this quickly. So we're going to come up with two equations of that form, which is the exponential form. So I'm going to use C equals, wait, what am I doing? 60 equals A e to the k times 5, so e to the 5k. And for the other one, we're going to get 2,800 equals A e to the 30k. I want to solve these two together. The easiest way to do that is to divide them. So if I divide the bottom one by the top one, we're going to get 2,800 over 60 equals, the a's will cancel, leaving us with e to the 30k divided by e to the 5k, and we can subtract those to get e to the 25k. So 2,800 divided by 60 gives me 46.444446. So I'm going to call it 46.467. We'll go to a few decimal places. We've got a bit of accuracy. Equals e to the 25k. Learn both sides. And you find out that k is equal to 0.154 basically. And if we sub that back, we can find that a is equal to 27.82. You guys might have been I think George was slightly more precise there, but it rounds. It's going to make a huge difference. But for now, I'm just trying to show you guys the method. So okay, so our exponential model will look like this. The cost equals 27.82 e to the power 0.154 v. All right, could you work out the cost of a 100-year vintage? Let's see what you come up with this time. Got anything yet? So if you put it all together, I think I got 13,572,599.7. So 13572,599.7, which is a lot. It's expensive. Yeah, 135. Wait, do you got 135 million? I got 13. Wait, maybe I didn't. Maybe I've missed a decimal place here. 1, 2, 3. Yeah, sorry, 135 million, even more than that. Let's write that again. 135,672,599. Yeah, hopefully tasty wine. Right, do we have time for one more? Probably not. But yeah, that's the idea with models. You could do a logarithmic model as well. All you need is 2 data points. So you could use, I don't know, again, just real quick for the last 5 minutes. We had our 2 data points here and here. So we've tried a linear model. So you tried a straight line. Tried an exponential model through the 2 points. We could try anything. We could try a log model, and you'd think that looks nothing like a log graph. Log looks like this. Yeah, I know, but we could stretch the log so it goes up through here and extend it that way as well. So we could fix a log model to fit the same data. Um, so we could try that. We could also try, weirdly, we could try a trig. So um, I don't know what. I'm just trying to think now what might fit. Tan maybe, or we could try and fit a. You could fit a cosine to it, I guess. I don't know. You could fit unlimited. You only got 2 data points, so you could fit anything you wanted to this model. You could fit a quadratic. You could fit a cubic. Uh, anything. So you could be asking the exam to fit stuff to a model. All you'd need to do is come up with 2 basic equations. So we're talking, if we used, for example, log, if we use y equals a log kx. If we use sine, we could use y equals um, a sine kx. If you wanted, you could do a shift. You could say it's y equals a stretched vertical sine with a x take k. You could translate it, and all of these would be relevant models. You'd be allowed to get away with whatever you did as long as you used both points and checked. Sometimes you might get a third point to see how good your model is, to see if you're anywhere near that third point. All right, that's going to be it for today. So you got your tests next week. Will all appear up on Moodle. If you guys need any last minute revision, we can do that next week, but obviously it won't be able to be anything similar to or anything. You shouldn't need it. You should just be able to go and do the test straight away. A week after that, we'll go over the test, and the week after that, we'll be starting the further maths topics, and I'll be explaining to you about options choices for next year as well. Cool. All right. I'll see you guys 2 weeks time, I guess, because won't see you for, well, not 2 weeks, just slightly under 2 weeks, because you got next week for mock. So good luck in your tests, and speak to you soon. Bye.